Right, so let's talk about strings. The goal of today's lecture is to equip you with enough knowledge to tackle the Google Billboard assignment. Most of that will be focused on learning a bit about strings, what they are, how they operate, some of the functions that you'll need, including substring and turning, strings into integers. Those are some big ideas. These ideas will also be useful in your coding bat problem set. It is a little bit longer this week. It's due next Friday, not this Friday, so plenty of time. Don't forget to do your reflections. These are especially important for my classes on asynchronous days, as I'll be looking them over and updating the attendance accordingly. Usual procedure. So, what is a string? Strings are a collection of 0 or more characters, and characters are defined as letters, digits, spaces, punctuations, even those funny looking symbols that you sometimes see. Those are all characters. Anything you can type on a keyboard is a character. Strings are also denoted with double quotes on them. The thing we share, me and Mr. Simon, is that both of us don't really appreciate strings. We have a disdain for strings, and I think that comes from our initial foray into programming was learning it in C, where you don't really have strings, you have character arrays, and everything becomes that much more annoying. You have it good now in Java. So notice strings, they're capital S, right? So in Java, strings are objects. So these string variables, really we should be saying, well, the weird thing about strings is it can be treated like an object, and then it can be treated as a variable, and it blurs the line between those two, which makes it kind of annoying. Nah, you're okay. Glad you made it. So first off, right, when we deal with strings, we got to think about how do I make strings? So here's the initialization step, and there's two ways to do it. First way is with a new string object that's using the constructor for the string class. Okay, we just started. So string s equals new string, and you give it an input, right? This is an input argument of, notice the double quotes, Java. That's the first way of initializing a string. The second way is using the string literal. So that looks like string t equals single quote Java. Okay. There's a subtle difference here. The new word will always create a new object, and the second way, using the literal, may reuse an existing string object. Until we talk about the memory a bit more, maybe next week, the second point becomes kind of harder to describe at the moment. If you want to be safer, I think it is better to go with the always making a new string object for now. Use the first way until we talk about the subtle difference. Cool. So that's initializing strings. So here are some examples of initializing strings and displaying them to the screen. Notice in the first line of code we have testing 1, 2, 3, 4. So inside this string we have 7 letters, 3 punctuation marks, 3 digits, and 3 spaces. Okay, which gives us a length of this string that we've made, the string called A, which contains testing 1, 2, 3, 4, to have 16 characters in total. Okay, so strings are not just characters, or not just letters that we're used to. Notice here, string B, it is initialized to contain the empty string. There's nothing between those two little quotation marks. So B, right, has a length of 0. No characters, no letters, no punctuation marks, no spaces and stuff. And then you're also introduced to the dot length. You've seen this with arrays and array lists, right? So size or length to get the how many things are within it. So at least that part, it's consistent. on the AP exam, you are expected to know these functions, operations with strings. The first one is called string concatenation. That's putting two strings together. I've only seen computer scientists use that word concatenation versus like putting things together. I haven't seen it in any other context. So that's using the plus operator with two strings, right? Adding strings. And we'll see some examples of that. Length, we've seen in the previous example, rather straightforward. Substring, not as straightforward, but we will get practice with this in the Google Billboard assignment as you're looking for substrings within 10 consecutive digits of E. Character at is something that used to be tested. It's no longer required, but you may find it useful in your FRQs. Equals, index of, and compare to. These last three we probably won't get to this lecture. We'll probably just focus on the first three. That's what you need to know. Actually, you need equals too, but we may not have time for it. We'll see. The AP test has a Java quick reference sheet. This is a little cheat sheet for you, so you have to memorize less things about certain functions, right? They tell you how they work. So the sections that's relevant to us are all these string functions. They tell you the inputs, and it tells you a little bit about how it operates, right? The outputs, returns, substring, from, to length. Length returns number of characters in the string object. It's useful. Every person is allowed one of these during the AP test. The concatenation. So notice in this short example, we use the literals, right? The second way of defining strings, just for example's sake. String A is capital A, string B is capital B. What do you think is outputted when we do print line A plus B? Type it in the chat. It's rather short. What do you think gets printed to the screen? Yeah, very good. As expected, right? The capital letters A and B. Works as you think it does. No spaces in between. The plus sign is special. There is no meaning to the minus, the times, nor the slash character in Java. The plus has special meaning. It puts things together. So now we go back to this idea of data types that we introduced way back in the fall semester. Let's try to concatenate or put together strings and integers, and let's see what happens. So here we have int nnum equals 5. Print line total square bracket plus nnum. I think we do use this kind of format for like 4-4s, right? Using the plus. This thing displays in green total with a little space next to it because that's where's my pointer? Notice the space, right? That's a part of it's in between the quotation marks. And then you see nnum. Notice there's no quotation marks there. It is of type integer, which is why you see the number 5. Okay, you're adding right now a string with an int. And the output, right, when you're using this concatenation is a string. String plus int equals a string in terms of data types. But you'll see that the order matters. Notice in this example, what gets outputted? Take a guess. X plus 2 plus 3. So you have a guess in your head. Let us see what gets outputted. What actually gets outputted is x plus 2 plus 3. Or, yeah, x 2, 3. What am I saying? No spaces next to it, right? You're literally sticking them all together. Now, for the second one, have a guess on what this one would output. Notice the extra use of parentheses. string. Yeah, take a guess on what gets outputted. Yeah. So this one, you expect to see x5. And what's going on here? Think about it like order of operations. With this one, you see a string first, so then it's going to treat everything else afterwards as, oh, if the user gave me a string, they probably want an output of a string. So then they go ahead and continue. Okay, 2, I'm going to treat it, although it's an integer, I'm going to treat it like a string. I'm going to stick it as is after the x, and then next with the 3. Whereas the second, in darker orange, you have parentheses there, right? It tells the computer, okay, hey computer, look at this first. I want you to do 2 plus 3 first. Oh, with 2 plus 3, you see two integers on the left and the right of the plus sign. It knows to add those together. 2 plus 3 means something to the computer without quotation marks. It means the arithmetic add. So then we get the number 5, in which case, after it addresses the parentheses, it does x plus the integer 5. And it becomes very much like this green example up here. Cool. So if you change it up, right? If you have an integer, I don't know if you should go experiment to see if you flip the order. If you have a bunch of integers first and then you have a string at the end, what the heck happens? The next useful idea we'll give you is turning a number into a string. I think this works with floats and doubles too, but for the Google Billboard assignment, you're particularly interested in integers. The short way to go about turning numbers into strings, right, so you can use these different string functions on it, is to add the empty string to it. So here we have the number 5. We're going to turn it that number 5 into the string that contains the number 5 and num plus that empty string. Just 2 quotation marks right after one another. When you print out s, now we see 5, which is of type string. Doing the reverse, right? There's this useful function from the integer class, parseInt. This thing takes an input of a string and turns it back into an integer. So here we have a string that contains 5 and the string version of 6. If we wanted to add them together like we did 5 plus 6 as we normally do in math class, we have to input them into this integer.parseInt function. This kind of stuff is like extra. If you use it on the AP test, it's legal, but you don't have to, right? And for our assignment purposes, Google Billboard, this is going to be probably useful to you. So this is how we get it to display 11. Double parse double works similarly for doubles. Cool. So now you know how to convert, you know how to initialize strings, you know how to put things together with strings, you know how to convert from strings to numbers, and vice versa. Click, click. One super useful function is called substring. Substring finds you parts of the string. You got to tell the computer where to start from, okay? So in this first version of substring, you tell it where to start from a number. So you treat it like an array, start at this position, and then go to the very end. You can see that from here. Oop, my little thing popped up. This is why I don't like presenting on doing the slideshow. So down here, right, when you look at the header from the quick reference guide, string, substring, int from. Return substring starting at from, ending at length. So really this one argument version uses this 2 argument version. It's not particularly helpful. Because you got to understand, like now it's like, okay, great. Now I need to understand how the 2 argument substring works, which is not so bad. The 2 argument substring is like a start point and an end point. Let's see some examples to understand what's going on. Unhappy dot substring 2 returns the word happy. Harbson substring 3, right, dot substring 3 returns the word bison. Emptiness beginning at position 9 returns the empty string. And then emptiness 10 causes an error. Where's my zoom annotate? Switch to this version. Okay, let's just write in some of those indices to see where these numbers come from. Unhappy, remember that in computer science we start counting at 0. So that's why you see start at position 2, which is why you see the word happy. From position 2 to the end is the output. Harbson 0, 1, 2, 3. Do one more, 4. Start at position 3, go to the end. This is why you see the word bison. Emptiness, remember you start counting at 0. 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 5, 6, 7, 8. Did I mess up counting somewhere? It looks right to me. So now you try to go from position 9 to the very end, which is empty. But then you see there is no position. I feel like I messed up with spelling the word emptiness. Did I? No. Nope. So this stuff is a little strange to me. I have to probably refresh my knowledge of Java on why that is. This counting, does the counting start at 1? You don't count the number? You know, now that I'm thinking about this, maybe that like these last 2 test cases leads me to believe that. I will probably have to go back and look. It could be the inclusive exclusive idea. Let me go check. So let's go back here, right? Get out of my way. So substring from to this. Return substring beginning at index from, ending at index 2 minus 1. We'll see some more examples. Yeah, I think it's inclusive. So if you start at 1, 2, yeah, we will clarify that soon. And you can test it for yourself. I could be off by 1 in terms of like, is it inclusive or is it exclusive? Next thing, substring 2, which may lead us to find that answer, takes in 2 things. You have a start point and a stop point. So you start at position, sorry, I'm getting confused because I'm looking at chat at the same time. So let's take a look at some examples. Okay, and let me go annotate to the screen again, and perhaps we'll find our answer. So let's start counting at 0. I do think that's the way to go, because Java is not an inconsistent language that would screw you like that. Okay. Hamburger, substring beginning at 4, ending at 8. So you include the first one. Shoot. Right, inclusive of the first number, and then stop right before this second number. That's where it gets annoying. So you don't include R, position 8, you stop at E, the sea urge. Smile, 0, 1, 2, 3, 4, and 5. Start at 1, including M, stop right before 5, which is S, we see the word mile. You subtract 1 from the second part of substring. So yeah, those are 2 equivalent ways of thinking about it, right? You can think about it as inclusive of 1 to 4, or inclusive, inclusive of 1, exclusive of the stop. Your choice. And after some more practice, you should see it. Stuff's new to us right now. Cool. I'll leave this up for a little while longer for you to stare at while the numbers are annotated. Close this. Inclusive of the start, exclusive of the second index, the stop. Clear my annotations. Double check the time. Doing okay. All right. Comparisons. So with strings, you have dot equals, and I think this is the first time we're seeing dot equals. Before this, if you wanted to compare something, the values contained inside something, you would use the double equal sign. Strings are a little special. They have dot equals. And how dot equals works is it returns true if two different objects have the same value. So let's go through an example. You have your first string called 1. It contains the word test. It is its own entity. Then you have a second string, and this is where I find it useful to draw out the pictures, right? So here is the first string. It contains the word test. Gotta be careful. Here's your second. Oh, I'll draw it out over here. Okay, here's 1, there's 2, right? This is 1. Contains the word test. Here's 2. Okay. Let's go on with our next example. Move this right here. And now, when we try to print this out, you should see the word true. We have two separate objects that have the same value test. Okay, and now you'll see the difference when we try to do double equals. It returns true if two variable names refer to the same object. So now, does 1 equal 2? True or false? Type it in the chat. Yeah, that's the weird part, right? It returns false because they refer to two different objects, right? In order for 1 and 2 to be true, it would have to look like, have to look like this. The picture would have to look like you have one object here, test, okay, and then 1 refers to test, and 2 refers to test. Good, you all mostly got false, okay? So notice that, like, to get this case to be true, if you use the way where you define it with literals, right? If you just initialize these strings with like no new keyword and just did quotation marks test, you would end up getting this test case, this situation, in order to get the double equals to be true. So because of that, you should definitely use dot equals. That behaves in the way we expect it to, right? You want to compare their contents, right? Not memory locations. The double equal sign doesn't compare their values. I think I said that correctly. Ugh, it becomes a mouthful. Okay, clearing my annotations. Click. Oh, okay. Look at that. So, ta-da, here we have that example that I drew out. 1 is a new string. 2 is pointing to that same string. So now we get this example where we have, I'm not going to draw it again, 1 equals 2. They refer to that same object, string, containing the word test. Oh, here's a nice one. So what's the output to the current line that's on the screen? Print line 1 dot equals 2. should this be true or false? Give people a chance to think about it. Yeah, and then the reasoning after people, a couple more responses, right? Think about why is it that answer? So you're using 1 dot equals 2, right? Remember, the dot equals refers to things between two different objects, right? If they have the same value. In this example, we just have one object, which is why... Is this what I wanted to show? It is, right? Did I mess up? 1 dot equals 2. Are they two separate objects still? They're pointing to the same thing. Yo, it's true. I thought it was false. They're the same object. Or is it, right? Because should then the output be... Ugh, did I mess up my things? Confused? Yeah, it is confusing, right? We think it should have been false. I thought it was legitimately false too. Two different objects refer to the same value. Let's go on, right? When in doubt, compare string using dot equals instead of double equals. Strange, right? So this is gonna bother me, right? Like the picture that I'm showing you, right, with... I should draw it again, right? With 1, 2 pointing to test, right? That picture should be correct. I'm pretty confident that this is the right picture. And I'm trying to piece together why this is true. In hopes, or in an attempt not to mess you up, I'm just gonna pause this and we'll come back to this when I do have a clear and concise explanation. I'll consult with Mr. Simon again. I don't want to tell you the wrong thing. All right. So initializing strings with literals, I think... Yeah, the second part doesn't say new, so it is not the new object, it is the same object. It equals itself. Since the variable here are initialized using the same string literal, this is the weird part, Java reuses that word test. It doesn't create a new one because you didn't use that new keyword. So this thing refers to the same object. When you do 1 double equals 2, you see the word true. When you do 1 dot equals 2, you see the word true. Is that surprising? Should that be surprising? No. It's still like this example that's getting me tripped up. This one here, right? I'll put a star by it. This one here, right? And I think, you know, I said I was confident about the picture, and then I look back at the next slide. I'm like, wait, are they actually two separate objects? Possibly. It's confusing because why is it mentioning two different strings then? Like, there's the literal string, and then there's the new string that we made. Oh, sorry. I'm just gonna pause because I'm gonna confuse myself and thus confuse you. So we'll get back. I'll get back to this second point. It is confusing, and we will need to. I'll clarify with Mr. Simon. Okay, here's a little rose instead as an apology. So, all right. So for coding bat, you should be able to work through a lot of these, and you should be doing a couple each day. Try not to procrastinate with this one, as it is been a while since we've coded, and it does tend to get confusing. So advice, right? Separate your if statements. Make sure your function will return a value in all test cases. Often it is like at the very end of the string or at the empty string. It tends to be test cases you fail. So try to address all of those. Okay. If you need help, send me an email. If we need to meet for office hours, we'll set up an appointment. Let me know. And I think that's all for today's lecture, as I just have 2 minutes left. Take care, everyone. Formally dismissed. Have a good Thursday.